Okay, notes for section 11 for areas of a kite's and related figures. So the area of a kite equals half the product of its diagonals. So if we were to draw a kite, the diagonals are located here and here, and the area would be 1/2 d1 times d2. So d is the length of one diagonal. This should say d1 is the length of one diagonal, and d2 is the length of the other diagonal. This formula can be applied to any kite, including the special cases of a rhombus and a square. Some people like to think of the diagonals just inside. That would be the length of d2, and this would be the length of d1. All right. Example 1 says, find the area of the kite with diagonals 9 and 14. So you would just plug it into the formula. Area equals 1/2 9 times 14. I would take half of 14 and get 7 times 9. So the area equals 63 units squared. The next example says, find the area of a rhombus whose perimeter is 20 and whose larger diagonal is 8. So if we know we have a rhombus, you know that a rhombus has 4 congruent sides. So if the perimeter is 20, we divide that by 4. Each side is 5. We also know that the longer diagonal is 8. So now to find the area, we would have area equals 1/2 8 times, we don't know, this diagonal. So to figure this out, what happens when you have two diagonals in a rhombus is that you form a right angle. And this part will be congruent to that part. So we have 4 and then 4 again. So if we were to look at this triangle right here, you have a right triangle that is a special 3, 4, 5. So if this part is 3, that means this part is 3 because of the properties of a rhombus. So our other diagonal would be 6. So then finally the area is half of 8 is 4 times 6. Your area is 24 units squared. This actually concludes the notes for section 11.4.